to discuss of reaction is the exponents of the concentration terms in the rate law of reaction. The last lecture we have discussed the expression of rate law. So this is the expression of rate law or rate law expression. And reaction order is the exponents of the concentration terms. So here, X is the reaction order for A, whereas Y is the reaction order for B. So the overall reaction order for this chemical reaction is the total of the exponents, in this case, X plus Y. The value of X or Y could be an integer, fraction, or zero. So let's say for this example, we have nitrogen dioxide plus carbon monoxide forming CO2 and NO. From experiment, that the order for nitrogen dioxide is 2 and for carbon monoxide is 0. So the overall order of the reaction is 2 plus 0, means that the order of the overall order of the reaction is 2. So the rate law expression, okay, can be written as rate equal to K time concentration of NO2 with the power of 2. 2 represent the overall order of reaction. In this case, the order of reaction with relates to NO2. So how do we identify the order of reaction? There are a few ways that we can identify the order of reaction, which is isolation method, differential method, half-life method, and rate law equation. So let's say for isolation method. So by doing experiment, we can change the reactant concentration systematically. Okay. Keep the concentration, for example, if we have the reaction between A and B as the reactant, forming C as the product. So in general, the rate law expression should be like this: rate equal to K times concentration of A, and we just put X as the order for A, Y as the order for B. So how do we use isolation method to identify the value of X and Y? First, we keep the concentration of one of the reactant constant and change the concentration of other reactant to determine the X and Y. So let's say here, A, small a, represent the concentration of reactant A, and small b represent the concentration of reactant B. So for experiment 1 and 2, the concentration of A is kept constant, whereas concentration of B is double. So the rate of reaction is determined experimentally. So there is a value that we can put here. And if we compare experiment 2 and 3, we can have a look here that the B concentration now is being kept constant, where the concentration of A is double. And we can measure the new rate. So let's say we rewrite R2, okay, over R1, the value of R2 over R1, okay, we can have the concentration of 2B over B with the power of Y, and we can calculate the value of Y. Let's say we take R3 over R1, okay, means the concentration of A, and this is supposed to be A, we can calculate the value of X. So let's look at real example. Okay. The kinetic study of the reaction, again, A plus B as the reactant, forming C. So from the experiment, okay, so we look at 1 and 2, we can see that the concentration of A is being double, where concentration of B is kept constant, and the initial rate or the rate of the reaction is recorded here. So this is one. This is to determine the order of reaction towards based on reactant A. And let's say if we compare 3 and 4, where concentration of A is kept constant and concentration of B is being double, we can see that there is a change in the rate of reaction. So we can identify order of reaction for B. So how do we do the calculation? So rate 2 and rate 1. So rate 2 over rate 1 is equal with concentration of A 0.2 over 0.1, okay, with the power of M, or with the order of reaction for A. M is order of reaction for A. So if we solve this calculation, we will end up having M equal to 1, means that the order of reaction for A is 1. So let's say what about B? Okay, the reaction is first order with respect to reactant A. So let's say what is the reaction order? Let's do the reaction order for B. So from the table, experiment 3 and 4, the A is kept constant, where B is being double. Okay, so rate 4 over rate 3, concentration of B in experiment 4 over concentration of B in experiment 3 with the power of N. N represent the order of reaction for B. So if we calculate N is equal to 2. So in short, the reaction order with respect to A is 1 and with respect to B is 2. So the overall reaction order is 1 plus 2, which is 3. So we can write the rate law expression. Okay, this is the rate law expression. Rate equal to K times concentration of A with the power of 1, means the order of the reaction with respect to A is 1, times concentration of B with the power of 2, means the reaction order with respect to B is 2. We can identify the value of K, okay, by putting in value from here, any value from here, the initial rates and the concentration inside the rate law expression, and then we can calculate K. We can also identify the order of reaction using differential method. So this is the rate law expression based on differential. If we look at here at the original, okay, by using differential method, it requires determination of initial rate of the reaction at various initial concentration of reactant. So it is written here, rate equal to dC over dt equal to R equal to K over A naught with the power of X. So let's look at the concentration. Let's look at example. Here we have hydrogen iodide, decomposition of hydrogen iodide into hydrogen and iodine. From the experiment, we can identify the initial rate of reaction. And we can see that from here, R, rate of reaction, is equal to K times initial concentration with the power of X. And it can be transformed into the following form of equation. Log R equal to log K plus X log A. Therefore, we can plot log R versus log A, and it should be giving a straight line. So let's say we have this example again, another example. We have the conversion of SO2, Cl to SO2 and chlorate. And we have a series of concentration of SO2, Cl2 initial, and these are all the initial rate of reaction. And if we plot the log R versus log concentration of SO2, Cl2, we can have a straight line. So from there, we can identify the value of X, which is the order of reaction for this particular reaction. We can also use T half value to identify the order of reaction. This is called half-life method. So what we can do is to plot the value of log T half versus log concentration. Okay. And the gradient is equal to n minus 1. And what is n minus 1? N is the order of reaction. So, and we can identify the order of reaction from the gradient value. So let's say you are given the value of the reactant concentration and the T half. So we can plot the log T half versus log concentration of the reactant. And from the gradient, we can identify the value of n minus 1. And finally, we can identify the value of n.